Hello, here will be our lecture of a CSCI 352, and after we complete the lecture, we will start. In a previous lecture, we talked about the Windows system, right? So how to how can we check those like bootloaders, BIOS, right? And for today, so we will talk about another OS will be the Linux. Okay, so when we talk about Linux, so before we have like Unix, and they're pretty similar, and mainly we will focus on different type of the digital forensics involved in the Linux system. Okay, and we need to have some concepts about knowing how the Linux file system it works, and how can we look into the Linux system, those logs of maybe certain directory, and then there's some commands we are going to use, and then maybe some interesting directories we may pretty helpful for us to doing investigation, and those commands probably you don't have to exactly memorize all of them, but pretty common, useful. Then you should also I will post an exercise under the quiz, so you will see week 9 related to the Linux command all this. And actually in the slides I already have an answer, but I would recommend you don't look at it and then just do the quiz, and let's see how much you understand. Okay, and after the course, and of course you are always feel free to check the answer. Okay, answer. So I just let you have some more interaction. So just remember, just reminding you, remember to do the question quiz like this. Okay, so no time limitation. And also, how can we undelete the files after we search for the content, and how can we undelete those files from the Linux system? So that's what we're going to do, and slightly talk about the history of the Linux. So in the beginning, in the 1969, we did a long time ago, we have Unix. So they already create, and then for the internal purpose, you see really, if you study computer science, you know the history of computers, and then mainly they're using for the militaries, and then in the laboratory. Okay, and then later they released to the public. Okay, and later commercial. Okay, and in 1972 they released the Unix, and then later stuff from the 1983 will be the GNU. GNU we will talk about. You'll see later. We'll mention about this one. So it's more like a graphic view. Okay. And then Minix, and then later when we talk about it will be the Linux will be 1991. And after in 2017, then really we have 100 of different Linux distros. And there's something related to distro as what you're using. I'm using right now. We have the Debian, Ubuntu, and maybe something like Arch. Okay, all these if you try to deploy those image on your server, let's say AWS EC2 or other service provider, you see there's so many Linux image you can use based on your preferences, or depends on your project. So you can choose, right? And when we talk about the shell and commands we're going to use, then of course we should have some idea about a different kind of shell. Okay, so the shell will be the terminals we are using. So let's say if I'm going to show you stuff from nowadays we have something like the shell even integrate with different AI. But long time ago, if you look at history, for those different Unix or Linux shell. So start with the beginning. The Bourne shell, so will be it's the first after the Unix introduced, so it will be created by the Stephen Bourne. Okay, really long time ago. The features, let's say you can type characters, and then if you want to delete it, so you can pick the backspace to delete all sentences, so they can recognize all those letter string. So all this will be given. So nowadays you think you're using it will be really basic fundamental shell, but actually they're really introduced within that time. But if we look at the history, the Bourne again shell, or right now nowadays we say the patch. Okay, and also other name, but I will cover this but later after slightly talk about history, because after the bone shell, it actually it comes with the seashell. Okay, so the seashell will be it should be introduced created by the Bill Joy. So actually he was working at UC Berkeley. And also they use it this one. Why you call it seashell? Because like the language really pretty similar to the C language. And then they can use double quotation mark to showing is the end of the input, and then they can use the like exclamation mark and come with the and sign, and it will show that you can get the parameter like this. So it call it like called a C shell, and then in later it comes out and we have the con shell. So it created by David Kohn. Okay, so it's also is working at AT&T. They're called the Bell Lab. But unluckily because the console was like kind of like designed for commercial, like for AT&T, because they have something similar to their business, and then they have similar system like Unix. Okay, so but they like create it as a commercial, then say it's not open to public open source. So that's why it goes back. And then people say, okay, why don't you come like goes back to unbound shell? So it's like again. So it's a born again shell. So we the bash. Okay. So after this, you will see they start from like basic input and like for typing strings, keyword like backspace, delete it, and then you can start to like getting parameters, and also they are more like TC shell. Also actually it's another like they can use much more advanced. They can adapt to the C shell, but there are more features and then con shell later. So nowadays, and you will see we have called the like S shell or like CS shells like this. Okay, so all these will be nowadays. If you look at mine, I'm using right now, so you will see I'm using the Z shell right here. So actually this I'm using. And let me show you. Let's say I turn on another terminal and can show you. Okay, so right here it takes some times. And so this one will be also like based on Z cell too. Okay, and a lot. And all the functions will be done more than like what we are using right now. So we can support like different commands, and then we have all the different features. Okay, so slightly introduce the history, and we have so many commands, and I will recommend because like when I go through the lectures, or sometimes you may already use it when I maybe under lecture or maybe in our lab exercise when I tell okay when you're using your bundle system or the Linux system, sometimes we will always use them. So but we in our lecture we'll cover it. Pretty common you will see we're using ls, right? So ls we try to list the content of the current directory, and sometimes we can pass the parameter like -l, so we will see those the ownership and then also the permission, all those information. And then we can, if we want to copy certain files, we can using cp. So these are commands like to copy one file to another directory. But of course, like if we need to copy the whole directory recursively, or like if we have a subfolders, subdirectory, then how can we do it? So we can pass a parity that that's out. Okay. So all this, and then we can pass copy the files to the directory. Okay, and then we have one is called make directory mkdir. So this one will be helping us create a new directory. If it doesn't exist, then we can create we can make a directory. If let's say if I have a I will have a subdirectory, and the parent directory it doesn't exist, then we can use the parser parameter called -p. So make directory -p, then you can have a subdirectory like this. So you can create this one, and cd will use a lot to change current directory to the new one. During the lab, like some of you will have some issue or problem. Why I try to execute the files, why so it doesn't exceed I couldn't find. Sometimes like because you are under certain directory, which is not the directory save your file or executable. Okay, so that's why you couldn't find it. Okay, so you need to change your own directory or pass the complete path. Okay, the path access to the files. So either will be fine. And then also we can remove the file using the RM, so we can delete or we call it remove it. If you need to like remove like some subdirectory, maybe we can pass that dash out and then like don't ask it using F, like force remove like this. And if you like this one with some like file name, of course you can like remove sometimes like copy passing different file type like using extra dot and then passing file the file type like dot like txt files or any other files like JPEG, PNG, whatever. So we can do this like. So these are pretty common, we see a lot. And when we like saying delete like RM, I say recurse like dash out and for deleting the directory, but also we have a specific like command you can use called the RMDIR. So it can use to remove the entire directory. So we can just pass it. So remove directory like this. And we have copy, right? CP, and then of course if we want to like move it, that means we don't want to make a copy, but this time I just like want to move it to another location. Then we can use MV. Okay, MV we can move a file, so we can move the file. So the first MV, and then we need to pass a file. Okay, and the folder, so the directory. Okay, so this is if I have different location, so maybe you need to using CD to change your to my files location, and then you need to pass a the complete directory. Let's say if I under like slash srv and then maybe website like www like this like public HTML whatever. So you can like you need to put the complete directory. Okay, so this a move and diff. So this one is like try to perform a byte by byte compression of two files. Okay, and tell you what's the difference about that. And let's say I already create two files and I can like demonstrate right here. So I can show you. Let's say I have a two test file. Okay, and then I have a test one file, and then like text two. So I just like hello and say okay. So I have two files. And then it will like trading bit by bit and showing the content right here. And then also we have like compare. So there's a compare comment. We perform a textual comparison of two files, and then they will tell you, okay, what's the differences between of these two. So I tell the difference, and then this time I try to execute is like try to compare. And if you look at my screen, I will have like using arrow. Of course, nowadays it looks like pretty straightforward, right? It should be common, but like for the shell, like in Unix long time, we say the bourne shell, and like supporting the go back directory like this checking. So it's like really enjoyed this long time ago. And right here you see when I try to compare, so they will tell like this file what's the difference, like stuff from which location, character location 3 and then line. So when you see the content, I try to like copy like hello and then hello digital like this HE. So start with start with the third one. So will be different. So will be like this. And sometimes when you see we try to output something, at least like redirect or like change it. So they will be like a redirect command. So instead we try to like display the output on the command line. Like if we try to like ls, but this time I want to like redirect to the file, or like if you will passing, maybe like I try to create a file, output it, and then pass it this one to a file, so we can use the arrow. Okay, so you will see a lot in a previous lab. So right now you will have a better idea to knowing, okay, why we're using this arrow. And later, for the rest, we are checking some process like later. So like related to a process, and we have some commands when we going to use. First one is like about PS. So we can like use like PS to show some current running process. So we already started. So maybe some any program on Linux is also can be the process. So I can change it to PS like this. Okay, I start something. So it's a TTYS right here. So you see the terminal right here. This is stuff from myself. Okay. So you see C shell Z. Okay, Z shell like this. So this the when I'm starting it, and then top for top is like showing the current running process. So whether we uses that yet or not. So it comes like more details. Sometimes if we want to like inspect like using process like which are running, or sometimes you want to check the program experience, not only the digital, for instance, sometimes that if for malware analysis, we want to see like which programs like occupy take most of processing power, CPU power. So we also can use top. So right here you see right now we are running the Zoom. I'm like recording it, so the PID, and then it's taking most of my processing power, like 30%. So it's high as my memories like this. Okay. So I can, and also like if you know like we can taking the like command C to terminate, really it comes out from the after the like the point shell, and then when we introduce it, they will like supporting okay, we can use like Control C to like terminate executing. So that's like also like you think okay pretty common, but actually using this one, because I'm Mac, using Control C, but for Linux system you can use a Command C to terminate. So it's really like introduce top, and then after top we have like FSCK. So this one will be the called the file system check. Okay, so this one will be like checking whether we're giving the partitions like working condition, good working condition. So we can like check the file system check. So we can pass the directory like which hard drive, and then at this, so at this will be like listing those like partitions. Okay, and then like passing partitions. And if you see there's something that related to showing the Windows like some partitions, so we can check the pretty similar. So even Linux we do have it to check it, and also we can mount if you see the second part of our lab. So we need to like download from the next NIST. So that one that image we doing after we unzip the DD the image file. So we try to mount it and then do the diagnosis and also the investigation, right? So we try to mount it to this one will be mount the partition, so we can like allow us to work on it. So you see. And so you will see right here is like pretty common. We use a lot in our lecture, and also maybe you will use it in the future too. Okay, and if you remember, we say after the Linux introduction we have GNU. So GNU is the also it's the network object model environment. So it creates, so it looks like this, and pretty similar. It looks like we are computer user home and then trash all this. So it is like, and when you move on, so we have the called K desktop environment. So it's called like KDE or like the Plasma. So it will giving like you have the home and then showing the browser. This one maybe later we have the Windows XP, something it looks like, and then the Windows. So you will see the history like they changing all the system. And of course, we do have other like Linux GUI. So you say a GUI graphic. So the common desktop environment, so CDE. So this one introduced originally developed in 1994 for the Unix system, and then later based on the HP system, you use as an environment. So we and then Enlightenment. So they were like relatively new too, and then they were like designed for the like graphic developer. So this is how it look like. But of course, nowadays we have a lot, right? Different release, different Linux version. Okay, and then it's very pretty common. We have some like graphic view. So, and if we look at the structure, like how do we like process, like how can the Linux like be a boot? It's the same. You see like we have a BIOS. BIOS is a basic because like when we need to load the our image to the memory, that's how can we start a system. So we have all the configs in a BIOS. So we paste to the MBR. Okay, so in the MBR will be containing like load or the main the image of OS, and then like we pass it the guru and L last in last output, and then we have two, and then we pass it also go down to the kernel. So during the kernel, okay, the kernel, so we will try to initialize all those like device, also like some other those devices may be a storage, maybe any like network adapter or some like USB or this like adapter, and then they will have a like remote to like protect from the remote change it to the protect mode like this. So it's like booting it, and then when they're ready, they start to like initialize and they start to run it. So in the run level, so what that means like okay, so it loads to the Linux system. Okay, so if you pay attention, like when you try to run the Ubuntu, so they start scanning those hardware, and then you see they're listing what they're scanning. So mainly after the lowest stuff from the kernel initialized, they were checking all those the devices, and then later initialized stage. So they were showing on the command line. Okay, and in the run levels, so right here we have different mode. Like if you see like the mode 0 to 6, so stuff about like LCD. So sometimes if you look at it, maybe let's start from the hardware will be 0, and then maybe under single user mode, then it will be like 1, LC1. And then if this are not used, so maybe depends on, you can define it, so it's under 2. So all this like you can find from directly LCD, like LC1, 2, 3, sometimes we can modify. And or if we can support like full multi-user mode, so without the GUI, and or like LC4D, so it's not user, so you can define your own, and then or LC5, so it will be a full multi-user mode, so with the GUI. So most are pretty common. Maybe we are loading like LC3, or if you are installing with the desktop version of the Ubuntu or like Debian, whatever. So it may be like if you're loading with the GUI, then will be like LC5, and with the LC6 will be like reboot. So after this, then we'll be running. Okay, so after we showing booting, then we'll move on to our logical volume manager. So it will be kind of an extra layer. So this extra layer can provide a volume manage of the Linux kernel. In our Linux, if we are running on the single system, so maybe just a single desktop or the server. So the primary role is it allows us to resize the partition. Okay, the logical volume manager allows us to like change the partition, like size, and or like we can create some like backup, so we can take the snapshot of the like logical volume. So we can do it. So is it how can we manage it? And for the Linux distribution right here, there's some examples telling you lots of like open source OS like Ubuntu, Red Hat, and Red Hat I think we barely use it like because they're enterprise level, and sometimes we have like before they were like you have to pay for it, and then Debian I think I mentioned a lot, and of course we have others, and if you're interested, you feel free to try. When we move on, so we'll be about the file system. Okay, if you like, we check the file system. So the Linux we are using extended file system. So ext, this we're using, and then they're using like 4, like extend 4, so it can support like maybe the volume of the like 1 exabyte, or like some like single files up to like some like 16 terabyte. Okay. Also we have like ext3 or like ext4, so they can support like all these 3 types generally. So general, maybe if you try to install the Ubuntu, like no matter the VM or something, maybe on your remote server with the GUI, or like if you look at it, if you try to configure, so you will see the hard disk, the when you try to format it, like you need to choose the installation, so it looks slightly different. Okay, so that's why when you see what's the ext 3 or 4, so you will see the name, and then depends how you would like to um like define the security. So maybe you can choose it as general or order or like write back. So like from this, like most secure, if you want to make it like general or less secured, and like encrypt. And also we have like the Windsor file system, so it can support the journaling. Also it can perform some well better when the hard disk have a large number of small files. Okay, and we're going to find fast file system, so it will be like as a, also we call it a Unix file system long time ago, so stuff from like UC Berkeley. Because when we talk about after the unborn cell would be the C shell, right? So C shell will be also introduced by the Billjoy. So Billjoy is working in the UC Berkeley, okay, at the time. And they create, so they will use the bitmaps to trace check those like free cluster, and then they will integrate the availabilities. Okay, so this is how the file system works. And when we goes on, and because for after we load into the Linux system, we are running, and then of course we have lots of different logs. And for the digital forensics, and we of course we have to investigate and look into those log files. Okay, so based on we have different most the by default those like log files will be under the var log, okay, slash, and then we have different type. If they have some fail user login, if we want to like fail log, okay, or like kernel log, so they will be the some message from the OS kernel. And or if something the items have been print, so we are like the IPR so log, and then and we have the mail. Okay, so maybe some like mail activity, email activity. So you will see that it's come with the extra. Okay, extra, that means any file type. So like, but the names come with the mail. Okay, and then or some like if we have the database, if you want to investigate the database, so we can check the log will be, let's say MySQL database activity, we save a dot my MySQL dot extra. So we can like try to check on it. And of course, we have something more. If you see the Apache or the Light TBD, these like they will be the server, like the web server. So maybe you heard about Apache, or if you take my class like web programming or others, I'm sure it's called, I mentioned Nginx, or Nginx will be the new one, light one. We can serve as a web server, proxy server, reverse proxy server. So they will all like safe right here under the log. Okay, you can find, and then so it will be application crash we save right here. And then also if we have some suspicious traffic, so we can like check it under the intrusion detection system log too. So we can like check all those possible logs. Then how can we view the logs? So you can check it, so we can open it, so any command you can work in it, so you can work in a GUI wherever text editor, so save it, so like we can like message, okay, message, and then PR, so we can check the tail, okay, or less or more, like so more information, so you can pass all these information to check the logs. Okay, so we can like view the log, we can use the message. Okay, so and we talk about like about all the file system, then we like go to like all the directories. Okay, move on. So the key directories, so they are kind of like important, like to letting all this like OS like to be like functioning well. So they also important, like they place into like seek out all those like evidence in an investigation. So we like need to have some idea from where can we find. Okay, so of course when you log in, if you know when you create a new bundle, we have called a root. So you know the root have a high permission, and sometimes we create the admin, and we try to create the sudo group, like like this. So root will be the home directory. So for the root user, so when you log into your Ubuntu, you will see the page. Like you see the CMD when you list with the cursor. When you look at it, it should be like in the root directory. So they will contains all the data for the administrator. So this one is more equivalent. So if we say root, that means equals to the Windows administrator account. Okay. So and then we have the bin /bin directory. So if you like check it, so we have some different type of files under like MD5, some like Mac directory. So all these will be like we can use, you can check. Okay. So you can like change to the bin and then list it, and you see all the commands we can use. And if you learn mail analysis, like all this, so you see all these like the command we're using. If some virus or like the malware try to like change it, you know, we have like third injection, like they will override. So they will try to modify those. Let's say they have a LS list file, and they will change the list file and try to create some executable file, binary file will execute, but they will hide the output. So it will pretend it's the same operation as for LS, but they will try to create something. They will inject certain statement. So you see it will be right here. And the SBIN will be similar. So, but that one will be counting some like binary file, but not intended for the like average computer user. So that one, those will be saved to the SBIN. So this is why you better see that part. This one and etc. So etc it contains all the like the configuration file. So no matter web server, bootloader, security software, or other application. Okay. If you remember, sometimes we in other courses you've taken like web programming, and I will show you. Okay, you maybe need to change the etc nginx. Okay, and change the size available, so you know under etc nginx one of the application we install, or like I told you to install like called the PHP fast CGI PHP 8.3 like this. Okay, so all this run under etc. Also, we have the init temp file. So all this will be like setting a boot up process and operation. So but all those like we are kind of like barely to touch this part, because it's like initial level for a system. They need to run. So they're current like in one level, some action process like boot or boot rate, like initial like default system initialize like this. This like the one we never touch this part, and you just need to know. Okay, we do have a like for the boot up process, like we say right here, and then will be the device files. So will be the interface to different type of devices. Sometimes we can check it. Okay, these are like all the devices connected, so they should be have a once you check it, this one we can record back to the no matter Windows or the previous time we are checking. So and those like devices have some meaning showing. So if HD we always say hard drive, and then FD would be the floppy drive, CD, okay, would be the CD drive. Okay, maybe you have no idea what's a floppy, and then you get interested. But right now it's like really fade out long time ago. I still one thing I remember when I was in my elementary school, we are still using the floppy. Okay, but later I think kind of like even before my middle school, they already failed. So we are like changed to CD, like mainly like everything using CD. So our main hard drive, so will be let's say like that HD0 like this. And then if we are something like mount, mainly if we're mount, so we can / MNT. Okay, so those are devices, they must be to be mounted, to be used. Okay. Let's say if you put me in USB, okay, we put it to mount. If you don't mount it, even the system detect, okay, there's some hardware connected. But if you don't mount, that means you cannot access to the USB memory location. Or their storage. Okay, I'm always checking this directory so we will know like what kind of current amount on the system. So we will find something more. And of course, we have the boot directory will show all those like critical. There's something crucial for the booting. So the bootloader like below or the group. So they will look into this directory. So load it. So when you know the application, when we after load, and we will check this boot. But when we loading, then we will check this part. Okay, so those like the kernel image commonly located in the boot directory, and then maybe if we have different users, so they will have some directory for the individual user. If you go to home, sometimes like under home, then you have different user account, so they change a little bit. And many times we have the var, vl, so it will some like data, so they will change during the system operation. And sometimes you will see maybe some website that will like content will put it under var or other like application content, or the pool will be like if your var's pool, so it will connect some like print queue. So if you are printing job, and we'll save over there. And then also like the post directory. So if you are like check the port, and it will be all like possible like post right here, and then with the ID, and then like C groups, IFB, K message page count, or like latency stats on the net. Okay, and then swaps is okay, time is okay right here, or like song information info. Okay, or the uptime version TTY, if you say TTY things, connection, all this will be the post directory. And also the shell command. When we move on, so we have like hundreds of shell commands, a lot. Some of them really useful and we use a lot. So why now? Hopefully, like during the lab and in practice, in practical, then you will like getting more familiar. Okay, something more like useful. Okay. And here we show you the example when I think if you remember we're using the dmessage, right? This command. So if we show dmessage, it will showing okay. So it will give us something like reusable. We serve like some locations like the range right here, and then like where the high memories is available 0, and then 60 like low memory available like this. And then those shown okay how many pages, if you remember the pages. This is like when you learn like operating system. Okay, so we have the page, and then like when they like initialization of the CPU, and then detail what's the processor like megahertz, how many megahertz. So all this information you can say. And there are some like questions. Okay, answer related, how can you use this command? So if you want to show the tree, you remember the tree, and then PS3. So we have a hierarchy right here at PS3. So you see, okay, we're showing like all the hierarchies listed, and then the file command. So we can like show all the what's the file of this one, and then JPEG file, image data, and then what's the JFI extenders. So this will be the color file. And right now we move to the next part will be how can we undelete the Linux file, so manually. So maybe we can move our system to the single user mode. If you do remember, how can we if you RC, so we can like change it to the single user mode, and then using grep. So like we this will we use this one too, or some other similar comments is okay. So we grab it, and then maybe we'll try to search it. Okay, grab it from the files from the def, if you remember. Okay, the devices from the partitions, and if you remember the arrow right here. Okay, so arrow, and then we should output to the files. So we can use the maybe the if we are only like command line editor, like you may be using can nano to check it, or we can view the file. If you have a GUI, then you can go to that directory to find the file .text. So we can like based on to search the text. And these are the questions. So you can like try to identify there are total 8 questions already posed on the like quiz. You can see under the is called the V9 Linux. Okay, so I give you 2 weeks time. So if you watch it, try to follow, then remember to complete it. Okay, no time limit, and then just like for checking your participation, or like I just checking if you're like looking for the slides. Okay. And just like quickly, I jump through. So all the questions, they all come with the answer. So try not to look at it if let's see if you have some idea. Sometime I mentioned about it. Okay, so you can do it. Kind of like NDKD Linux. So last part. So this one have a different type of tool we can use. We can use like as a like quality control tool to like complement like also for instance, like FTK. FTK is one of the tools we can use, or like NKs, and also like auto find, and also it's a like web-based like graphical user interface. So for the command line tool, okay, so key. So if you remember, we also use this one too. So it is coming. Here's some screenshot how to use it. It's the web-based, so you can like using on the fly, and then you can see, okay, maybe you don't need the like JavaScript to use run it. So remember to turn off it for the security version, and then you can like input the host name. So like the host right here, giving a description and giving the time zone. Okay, optional, or like the times that see adjustment. So this one may be like how many seconds will come to the time clock. So maybe you already not thinking what's the time clock, because right now you will synchronize with the server. Okay, the time server, so you can update sequence like automatically nowadays. And also like what's the full path location of to the image file, so we can like get it where we download, and then which type do they a disk or is a partition. Okay, how this, and then how can we like import it. So we just like copy or like from the system link like this, like send it to the symbolic link, so we can send it. Okay, and after we load it, then you can showing, okay, you can like choose like which volume like you want to analyze. Okay, or like you can add others. So so far we quickly go through. So we talk about the Linux system, and also like how can we there's some directory, where's the location of the Linux logs directory. Okay, and then what the some directory is possible, like where should we go to find, okay, some pause, or some maybe etc. Okay, right here. Okay, those are commands that we also mentioned about it, and then we talk about how can we use the grab and output it. So do it as an entity files from the Linux. So for this it for our lecture. Thank you so much.